Hey everyone, welcome to the 2024 World Hydrogen North America. I am joined here right now by John Richmond, the Senior Sales Manager for Thermo Fisher Scientific. How's it going?
Not too bad. Thank you, Tyler. Nice to be here, and thanks for the invitation to speak at the conference.
Anytime. Is this your first year coming?
First year coming, but definitely not the last.
Excellent, excellent. So, how about you start by explaining Thermo Fisher Scientific and your role with the company?
Of course. So Thermo Fisher Scientific is a very large company that is one of the world leaders in science and science-based technology. Our interest recently has been in the area of clean energy. So we have a very clear focus from Thermo Fisher to be involved in this, supplying technology solutions to customers who have projects in this area. So the areas that we particularly work in, as well as hydrogen, we work in carbon capture and sustainable aviation fuel. The technology that we have here at the show and what I'm going to be talking about is Raman Spectroscopy and how Raman Spectroscopy can provide a solution for compositional analysis of streams that are used in this industry.
Excellent. So, do you want to kind of tell us about some of the clean energy or decarbonization projects that Thermo Fisher has going on?
Yes, of course, be happy to do that. So in terms of clean energy projects with hydrogen, we're working in a number of areas. Not many people understand, but hydrogen exists as two isomers, the ortho form and the para form, and it's a temperature equilibrium between them. At room temperature, it's 75% ortho and 25% para. Now, what's important is that for transportation and for storage, we need to do liquefaction of hydrogen. So we need to turn it from the gas phase into the liquid phase. For that to happen, we have to change that equilibrium from the ortho to the para form. So we go at low temperature over a catalyst, and we're able to convert hydrogen from ortho down to 99.1% para. Why is this important? It's important for storage use. If you try and store the ortho form, you run into problems with boil off. You can lose 70% of your hydrogen in a very short space of time. So the para form is much preferred for storage and transportation. It's much more efficient to do that. So that's why it's important to convert from one form to the other. Using Raman spectroscopy, we can monitor that complete conversion from ortho to para. And we work with our partners at MIT, Massachusetts Institute of Technology. We're doing a lot of research with those guys in this particular area. So that's on the hydrogen side in terms of conversion. We're also working in the area of decarbonization. So one of the key projects that we have out of many is to decarbonize natural gas feed for power generation. So we can do this by blending hydrogen into natural gas up to, at the moment, 60 to 70%. So now we're burning more hydrogen than natural gas, which is then reducing the amount of CO2 emissions which are there. And then the final project that I'd like to talk about is a really interesting one. And this is in the area of nuclear fusion. We can take deuterium and tritium, which are isotopes of hydrogen, as we know, and we can fuse these together at very high temperatures in excess of 1 million degrees in a plasma inside a nuclear reactor. What that does, it fuses the deuterium and the tritium to form what's called helium, which is helium-3. In doing so, that produces a huge amount of energy, and then that energy can be used, it's very clean energy, and then that can be used power grid and powering buildings and towns and cities. So it's a really, really exciting area to be involved with.
Wow. Well, I look forward to seeing the progress on all these different areas that Thermo Fisher is working on. Do you have any other specific projects you want to speak to?
So in the clean energy area, we're also working with carbon capture. So again, decarbonization, taking CO2 out of the atmosphere and then converting it into useful building blocks, which can then go into making products such as Sustainable Aviation Fuel, or SAF. That is another big area for Thermo Fisher. And then the other one is in the area of battery recycling. So we're involved in the circular economy.
It's awesome to hear, John. Well, thank you for joining us, and thank you for attending the conference this year. I hope to see you again next year.
It's been my pleasure. I've enjoyed it, and definitely I'll be back next year.
All right.